easy but necessary techniques on Arduino Ide app, how we can use them, such as declaring variables and also using a very special function called as analogWrite. So, in the last session, if you have not seen, please watch it. And in our analogWrite function, we had learned how to we have learned how to switch on and switch off, and we had also learned how to declare sorry, not variables, because we are going to learn it today. We had also learned how to declare connections, how to declare them as output or input, and this is really very necessary. No code for Arduino can go without this. So this was the basics, and we had started to code in our Arduino IDE app. So now we are going to declare some variable and use analog write function. Wasn't it interesting? Because analog write is just different from digital write. It means something more, and it's really something more than a digital write. I will be explaining you more about analog write function and how to declare variables. So let's start and open our Arduino IDE app. So I'm starting to share my screen, and yes, done. And now I'm going to Arduino IDE app. It always takes some time to open, but no problem. Open up, open up, open up. Okay. So this is the Arduino IDE app beta version, which I had told you in the last class. I'm opening a new window in which we will be coding in Arduino IDE beta version. Yes, it's open. So let's start. Now, declaring variables, all this can be done. But the basics, which are of introducing a connection, that are the basics that must need to be done before any else connection. So first we will be declaring a connection again with the LED pin. You know why we are learning to use all these connections first with LEDs, or you can also use buzzer instead of them, because they are the basics. You can do trials, errors on them, because first you get a bit practical and perfect about that, and then you can go on other things, other high level things. Okay, so constant, our LED pin, most favorite, or let's take it as buzzer pin. We can connect buzzers positive terminal to the digital pin. So now we'll be connecting it to 12, digital pin 12, and then introducing a variable. This we'll be doing in the last because it's the most interesting part, isn't it? So you might not think it to be interesting because it is the first time you in my session. So we're doing it the last. We'll classify this as output. And while I'm writing all this, you please recall why I have written constant buzzer pin is equal to tell and pin mode. Recall all the things which we had learned in the last session, how to introduce connections and how to use pin mode to declare it as output or input. So pin mode, our buzzer pin, comma, what will it be? Output. Yes, it will be output because it gives output. If it is input, we will write input. Okay. So once that is done, we'll go and now we will switch it on, switch it off, but not that. We are going to use analog write function. An analog write function takes a variable. For example, you may set variable's length like maximum value of the variable as 255 and the minimum value as 0, and the max value when it goes to that value it will supply maximum voltage to buzzer pin. And if you reduce the voltage, for example 100 or 90, 70 or 0, the voltage will decrease as per the number from 0 to 255. So we'll be doing that. And now comes the most interesting part, declaring a variable. So this is int. Isn't it amazing? Int. Like constant means a read-only variable, which will be constant. Its value cannot be changed. However, its value can be read by the computer. So int means a value which can be changed, which can be read, and can be used in many functions. Int. So we'll give like its buzzer. So we'll give it as volume. Volume is equal to, we'll assign the max value as 255. Okay, done. Now we have, as we had done here, constant the connection name or the read-only variable's name and its value. In a similar way, int the read and write variable name and 255, and then analog write function. Just as digital write, how we wrote it as digital write connection name else, it will be the exactly the same, but just we'll be changing digital to analog. Then it's simple. The format is same. Just instead of digital write, we'll be giving analog write. So analog write, the connection name, which will be buzzer pin, comma volume. Okay. So now I'll going to tell a bit about it, and then we'll be giving a delay. Recall why we give a delay. Set a time interval, and then delay of 1 second. That means 1000 milliseconds, and the value must be entered in a milliseconds. And then, so I will not be explaining the whole code now because I will first write and then explain. So what happens is that when I explain, you can read at the same time, and it will be more clear. Okay. So now again analog write and the connection name buzzer pin, or we will first declare volume is equal to 255. It will set the volume of the buzzer pin as 255, and here we will reduce the volume to its half, which is 125.5. Sorry, not 5, 127.5. That means 255. And then we'll write analog write buzzer pin, comma, volume. And then again a delay of 1000 seconds. Sorry, 1000 milliseconds. And then again we will change the integers value or read and write integers value as 20 to be the lowest value which is possible. And never miss to give a semicolon, as I told you in the first session, because semicolon is what separates one line from the another. No semicolon means no gap, and that gives you an error. And then analog right, again our connection name, comma, volume. Okay, so this is what will be there, and again a delay of 1 second or 1000 seconds. Sorry, 1000 milliseconds. And now the code is ready. We'll just upload it. But before that, let me tell you the comments, set part, and etc. etc. We'll add the comments. Constant buzzer pin. What is that? Creating a connection. Read only variable. Okay. And after that, in this line, the comments are. So you know, right? Buzzer pin is what we have made a read-only variable for creating a connection. So we gave a name to our variable and assigned it a value which can be only read. So that value will be our connection number. Okay. So whenever we use buzzer pin, what will happen is if we use in digital write, the digital pin 12 will be supplied 5 volts. Okay. So this is how a connection is created, and then int volume, creating a read and write variable. Okay, so now we have created a read and write variable. What's the difference between read only and read and write variable? So whenever you write code in like in JavaScript, there are two variables: normal var. I will be writing it in the next line for making it clear. Var. Okay, you see. So that is one, and the another one is const, only const, to give it a constant value, which is again a read only variable. So what happens is read only variable allows you to read and write variable allows you to read as well as write the values in the variable. Okay, one simple example is your computer. Some computer programs may only be read only variable. You can't change anything in them. And some may be read and write. For example, your normal Microsoft Word documents or PowerPoint, you can read and write. Or sometimes when you are downloading a file from internet, sometimes it may be only read only, isn't it? This is what is difference between read only and read and write. But variable, okay, not files. And then we classify the connection as output. This is done. And now in void loop, the main code. All the logic lays in the void loop function because it repeats itself, and any mistake may make the whole code waste. Okay. Now in void loop, what do we do? We give a variable volume value of 255. So what happens is we here give the variable volume. So we had created a variable, isn't it? We give it a value of 255. And then in analogWrite, what do we do? We provide voltage according to variable volume. So what happens is analogWrite buzz up in volume. What we had seen in digital write was, I will write it below so that we can compare it properly. Digital write, digital write, the name buzz up in comma high, isn't it? So we can write high or low, on or off. But for example, if you want to give it a varying voltage up, down. For example, 5 volts, 2.5, 3 volts, 4.50 volts. You cannot use digital write because it has only two options, 5 volts or 0 volts. That's done. So we can't use digital write for that. So this is why analog write performs the work. It provides voltage according to the variable value. Okay. So you understand, right? What is variable value? We are give the variable a value of 255. So it will provide a number like 255 value volts, not 255 volts, but 255 value, like fractions, right? So 255 will be 5 volts. Then 1 to 7.5 will be 2.5 volts, and 20 will be very less, nearly 0.1 or something like that volts. So this is how we can give varying voltage. Okay, varying voltage to our LED or buzzer or anything using analog write. Whatever value of the variable you give there, the value will be given, and then delay. Here we give a delay, simple, give a delay of 1 second. So now I will be copying this, writing it here, and we provide voltage according to variable value. This will be also be copied because we have done the same. What actual changes we have made is only we have changed the variables value. The what is our variable first? Our variable is volume. So we change it value of from 255 to a little less, then again little less. And because it is loop from a little less after 1 second, which is here, it will again be 255. Okay. And then we again give a delay. So you know what I'm doing right now? That is called as commenting of code, which makes some like Whatever you write here does not affect your code. However, the reader may use them as a reference. So this is why I'm commenting the code so that you're a beginner. So that will help you to understand how to why I have done this. Giving we give the variable value of of 20. Oh no, I should be just copying it and pasting it, and here I am doing all the right job. So we will simply copy it and write it. So now I'm going to give a short summary of what we have done here. So first of all, we created a connection. It is the most necessary, and you cannot skip this. Okay, so that is fixed. You cannot. It is your choice whether you create a variable or not, because using analog write needs a variable, and it's your choice whether to use digital write or analog write. Okay, but creating a connection is necessary. Then comes the void setup. In void setup, what we do, we simply classify it as output because it is a buzzer. In mode, the connection number and sorry name, and then it output, and then in volume we give it as 255. What is the volume? We give volume the value of 255 because we are using buzzer. If we using LED, you may use brightness. The brightness is 255. And then analog write buzzer pin. What is the connection name? Similar. Like if you recall digital write, connection name high or low. Similar thing. Just analog write, then in shift 90 brackets, buzzer pin, which is our connection name, and what we give here is the variable according to which the voltage will be supplied to the buzzer pin or the connection which we have given. Okay, so voltage will be supplied according to that. Understand? And then we give a delay of 1 second. Here we use delay and then 1000. So 1000 is given because we are giving a delay of 1000 milliseconds. We cannot give it in the format of 1 second. Okay, because 1000 milliseconds is equal to 1 second. And then we, after a delay of 1000 milliseconds, we change the value of volume to 127.5. Why do we change? If we change volume, then the volume of the buzzer will also increase or decrease according to the variable value. Okay, because we are giving the variable as the fraction of voltage which will be supplied to the buzzer. So if the variable will be reduced, the volume or brightness, if you are using LED, brightness, if you are using a buzzer, then the volume will be reduced or increased. If the value of variable is increased, the volume will or brightness will increase. And if you're using a LED, and if the value of volume is decreased, the value will decrease. Simple. Increase of variable will lead to increase of the brightness or volume, and decrease of variable will lead to decrease of volume or brightness. And this is how it works. And then again, after 1 second, we change the value to a little lesser number, which is 20. So first 255, then 127.5, and then again a lesser number, which is 20. And then analog write our connection number, sorry, name, buzzer pin, and then volume, delay 1000 milliseconds or 1 second. So this is the actual play. You understand? Actual play is the analog write function, which helps us to provide varying voltage. Now we'll be converting 255 to 5 volts. Okay. So when we divide 255 by 551, we'll get how much fraction of voltage will be supplied. So I'm simply opening the calculator. I don't want a so big calculator. In short version, it will be more better. And now we'll be coming to know if we give a variable of 255, how much voltage will be supplied. So 255 divided by 51 and is equal to. So 5 volts will be supplied. Now we have given 127.5. So I will cancel 127.5 divided by 51, 2.5, as I told you, because it is the half of 255, you will supply 2.5. And then 20, which is the least. Now 20. Oh, 20 divided by 51. 0.39 volts, which is quite less. So you understand, the more the value of variable, the more will be the volume of the buzzer or the brightness of the LED. So this is the actual play. Analog write the name of the connection and then the variable. Then you can reduce the variable or increase the variable's value, and then again use analog write the connection name and the variable as it's the voltage which will be supplied. Okay, I hope you understood it. And let's do a final job, which is saving it, and then we'll be saving it. Okay, in our Arduino project core, here save, done. Now I'm opening it, and we will be verifying whether it is correct or not. Arduino project score, sketch March 30A. Okay, so it's opening up, and it's opening up. Open up fast. This is why we use Arduino beta version instead of this, because it's quite slow. So we have opened it up, and I hope everything is clearly visible. First, we introduce the connection, then a variable for according to which the brightness, the volume of the buzzer or the brightness of the LED can be changed. And this is done by analog write, by which if we increase the value of variable, the brightness of LED will increase or the volume of buzzer will increase. And if we decrease the value as we have done here from 255 gradually to 127.5 and then to 20, then the volume of the buzzer will decrease. And if you have attached the LED, its brightness will decrease. And the connection is done to digital pin 12. Isn't it interesting, friends? So that's done. Thank you, friends. Let's meet in our next live session. Bye.